All right, so you have two products that come from the electrochemical activation process. You have a sodium hydroxide cleaner degreaser, and you have a hypochlorous acid tuberculocidal strength disinfectant. Both are generated at the same time with salt, water, and electricity. Just to demonstrate the effect of both products, we have a sesame seed oil here, a really viscous, really oily substance. So it's very sticky and oily and greasy. So to show you the power of the sodium hydroxide, when it comes to fighting oil stains or anything like that, it completely emulsifies it. So you can clean up those grease stains really easily. Now with the hypochlorous acid disinfectant, you use a high-range chlorine test strip. We want to test to see how many parts per million this disinfectant is. So it's clear you can use this with any standard chlorine-based disinfectant. So we use these just to demonstrate the effect of the hypochlorous. So you can see here we've got a really powerful 500 to 600 parts per million disinfectant here. But the difference is I can spray this on my hands, I can spray this on my skin and my clothes, and it's not going to damage anything. It's very safe. In fact, our bodies actually make hypochlorous in our white blood cells to fight infection. Super powerful, super effective, but very safe. Okay, so a lot of people want to know the difference between hypochlorous acid and regular traditional bleach. A lot of people don't realize that traditional bleach actually uses hypochlorous acid to kill germs. The difference is pH. But before I demonstrate the pH, I want to demonstrate the fact that this diluted bleach solution that everybody goes to for disinfecting is the same strength as the hypochlorous acid solution that we're using. So when I dip this here and I use this high chlorine test strip here, I've got 600 parts per million. If I dip this hypochlorous acid disinfectant, I have the same parts per million. So we've established that baseline that they're the same product as far as their chlorine level. But if I put this pH probe here inside of this hypochlorous disinfectant, it's going to land at about a 6.3 to 7.1 range, which is perfect. So let's compare that with this bleach solution. So as you can see, the pH is climbing and it's going to level off at about a pH of 12. And what that means is that the higher the pH, the more salts that you have in the solution. That's where you get that milky white residue that happens with bleach, where it bleaches your clothes, it damages surfaces, and is very abrasive. As opposed to hypochlorous being a neutral pH, there's more free available chlorine in the form of hypochlorous. If you think of hypochlorous, gaseous, versus hypochlorite, which is bleach, the ITE is the salts that are in there that raise that pH. So when you think about it in terms of why a germ is more susceptible to hypochlorous at a neutral pH, is because it doesn't put up a resistance. It doesn't sense that high pH. It says, hey, this is fresh, this is easy, this is something that I'm going to let in like a food source. So once it lets it in, it's like a Trojan horse. Once it's inside, it ruptures the cell wall, it kills the DNA of the germ, and it completely destroys it, as opposed to bludgeoning it to death with a high pH.